Well, hello and welcome back to the channel. It's been a while since I've added any content to the YouTube channel. For most of that time I've been working on this project, which is Marvin the Paranoid Android from the TV series Hitchhiker's Guide to the Galaxy. So my version of Marvin is half scale, so it's about 1 meter tall. It's mostly 3D printed. The arms and head are posable, and I also have options to fit electronics inside of Marvin, so that's Marvin voice and some movement. So here's a animation from Fusion 360. Fusion 360 is the CAD package that I use to draw Marvin up. I didn't find a lot of information about measurements on Marvin, so most of it is from screen captures. So Marvin's not 100% accurate, but I've tried to make it as close to the TV series as possible. So some of the features of Marvin. So he's got LED eyes, you can fit them in there and the eyes will light up. Also there's posable head, and so the neck rotates. The electronic option will give you a random head movement. The shoulders, elbows, wrists and hands are posable, so you can put them into a position and they'll stay there. The GPP panel, or the Genuine People Personality panel, so you can control the volume of the audio of the sound chip clips, change the eye brightness, and also change the head mode movement, so you can get it to move or not move. So I intend to make the project available for download. The site, I haven't really worked out which site yet to do that from. It may be printables. I've previously used Thingiverse, but their file structure is a little bit odd for multiple files, so I just wanted to make it easier to have the documentation and the files in separate folders. But I'll put a link in the next video when I've sorted out where the files are going to go. I'll get on to the project now. So this is the build part, the prep and paint. So I'm using some NTM paint this time, and a slightly different filling system for the 3D print. Using blade putty, just standard blade putty, that's the one that's available locally, and mixed it with acetone to thin it down to like a cream consistency, and then painted that on with a paintbrush, and then sanded that off with 180 grit wet and dry. The process wasn't too bad. It was a bit easier than just putting blade putty on straight out of the tin. Once the finish was okay, I sprayed it with spray putty, which is normal, and sanded it off with 300 grit. Because it's NTN paint, I'm using NTN white primer, and I chose London Grey, NTN London Grey. I'm not saying that's the right colour, but it was close. After a couple of coats of that, I'll put some clear acrylic varnish on top of it, because the 94 is a matte finish, so you need a varnish on top of it to give it a satin or a gloss finish. And the black parts, I use NTN black, and again sprayed it with the clear varnish, the gloss varnish. For the metal parts, for the metal look on the greeblies, I use Vallejo airbrush paint. I've used these a couple of times before and they've been okay. So this is the metal colour version. to prep the surface, I use their black surface primer, and then most of the parts were done in metal colour aluminium over the black. It's all done with an airbrush. You can paint it on by hand, but it's not quite as good. And then finally I put the metal colour varnish over the top of that to seal the metal colour. Some of the parts I used this silver just to add a little bit of extra contrast. So the finish, I was really happy with how the metal parts finished up. So we'll talk about the assembly part of the project. First up will be the head, but I will talk about the other major parts of Marvin in upcoming videos. So I've done assembly diagrams for all the pieces. The head is in 4 sections. There's 2 center section, which is left and right, and then the side sections. If you're going to use the LEDs for the eyes, you need to glue them in place before assembling the center section of the head. The 2 side pieces, the left and right side pieces, you can print them out as one piece, so all the greeblies and the ear will be printed at once. Or you can choose to print the side piece without the ears and the greebly, and print them out separately and glue them on. It might be easier to prepare the parts separately, but in the end I went with one piece, and that worked out okay. Just a little bit of fiddly sounding here and there, but it worked out okay. The ears also have an option, so you can have a smooth plate on the ears or a grill plate on the ears. It was really hard to work out in the screenshots that I had whether that was smooth or grilled, so I've made 2 plates so I can swap between the 2 if it becomes a bit clearer later on what was used on the TV series. So here's an early version of the head, and you can see that the side piece has separate greeblies and ears. The center section in the head is where the LED for the eyes fits. The LED is a 10mm red LED. So as I said, this is an early version. The nose section I've removed from this and made it a separate part because I had problems with the overhang when I was printing the head section. So there's an early version of the separate nose. So this is the side section. It attaches to the head there's 2 locating pins just to help you align it all, and then because this is PETG, I just used 10-minute epoxy to glue the parts together. And here's the optional separate greeblies. Like I said, you can print this out or print the side complete with all the greeblies and the ears already in place. So the ear has changed since this version. As I said, that's the grill version on the side, but I also have a plain version as well, and they clip on separately. So when you print this one with the greeblies missing, without the greeblies, you have to print the ear separately. If you print the side complete, the ear will already be attached to the side, part of the print. And that's just the lens keeper for the eye. I'll talk about the LEDs for the eyes, because before you glue the centre section of the head together, you need to, if you're going to use the LEDs, you have to have them in place to start with. So the 10mm red LEDs, I like to check the LEDs to make sure they work with a button battery. This is a 3V lithium cell. Normally the long lead is the positive lead. So there is a bleed resistor on each, current limiting resistor, sorry, on each LED. So they go back to the ESP32, which I'm using in the electronics part, and a common ground that goes back. So there's, in this case, there's 2 yellow wires for the left and right eye, and a common. It doesn't matter which way the left and right are, because they're basically driven by the same signal in the ESP32. Just, it's important that before you glue the head together, you need to check that the LEDs work, because it's a problem if they don't. So just a brief section about painting the head and the eye mesh. Part of the files are two are these eye patches, I call them, to go over the eye, just so you're not getting paint inside the head and they get removed afterwards. You don't need to use them if you don't want to. The mesh on the head is standard flywire mesh that you put on your door or your windows, and there's a template there to cut that out with. I just glued the mesh onto the mouth with canopy glue, which is a really thin PVA glue, and I've used the mouth template just to hold it in place, to hold it all flat. So the transparent red perspex or acrylic eyes, I just use 3mm acrylic. There's 2 templates in the file set that you can use to cut the perspex out with. I just found it easy to mark a line 26.4mm from the edge, cut it, snap it off, then use a coping saw. I marked the perspex out with the template, then cut it with a coping saw, and then just filed it so it fitted a bit better inside onto the head. So there is eye frames that go around that to hold it in, so you don't have to be too close. Those eye frames, again, I glued in with the canopy glue, which is just really thin PVA white glue. So there's the head with the red lenses and the red LEDs in there. We'll just have a look at the head completed. So this is half-size Marvin. So this is the ear, which that's the plain plate, but there's an optional grill and all the greeblies there. This one was printed in place. There's the mouth with the mesh on it, and for want of a better word, the black chin. So the upper neck has been glued onto the head when I was finishing it. There's some locating pins there. That's all part of the file set, just to help that locate to the lower neck piece first. And the wires for the LEDs. Just talk a little bit about the lower neck. So I used some aluminium tape there. So I just got it off eBay. It's about the same thickness as standard cooking aluminium foil, but it has a it's self-adhesive. It was a little bit of mucking around to put that on. Did take 3 or 4 tries, and I also put the same tape on the shoulders. I was reasonably happy with how that turned out. but could have just painted it silver or aluminium as well, I guess. So the lower neck has 4 neodymium magnets in there, and they correspond with the 4 neodymium magnets which are attached to the servo in the body. So the head is magnetically coupled to the servo that's in the body. Hopefully this diagram sort of makes that a bit clearer. The yellow neodymium magnets there, they're north-south, they want to attract each other, and when the servo turns, the head turns as well. So this is not on my idea. I used it in a BB-8 build a couple of years ago, and it worked okay, so the head stays on BB-8 really well. If you're not going to go with the electronics option, you don't need to add magnets to Marvin. But if you are, and you want the random head movement, you need to add 4 magnets to the lower neck section, and 4 magnets to the servo holder or servo arm in the body. So the magnets in the servo arm in the body need to be attracted to the magnets that are in the lower neck section. That's where the magnetic coupling comes from. So when the servo rotates, the head will rotate as well. The problem is that when you buy the magnets, they're not marked north or south, so we need to work out which ends are attracted to each other. So here's the servo arm in the body, 4 magnets with blue dots on it, and the other side there is the lower neck section with 4 magnets with red dots marked on them. So when you get the magnets, they're in a long strip. So I just got the first magnet and put a red paint pen on it. Then took that magnet off of the strip and put a blue paint pen at the other end. So when the blue paint pen dried, I got the next magnet along, and the end that attracted to that blue dot, I painted red on the second magnet, and the other end of that magnet, I painted a blue dot. Then I just kept going down the remaining magnets until I had 8 magnets. So what that means is that any of the red face of any of the magnets could be attracted to any of the blue face of corresponding magnet. That way I could just put facing ends of the magnet on the lower in the servo arm, and the red facing ends into the lower neck section. That way I knew that those 4 magnets in the servo arm would be attracted to the neck section. If you haven't fitted the 10mm red LEDs in the head for the eyes, you don't need to modify the M8 neck bolt. But if you have fitted the LEDs for the eyes and the head, you need to modify the M8 neck bolt by drilling a hole through the center of the neck bolt. So here's the orange piece is the neck bolt. So the cables have to run from the head to make connection into the body. To do that, there's a 5mm hole in the neck bolt. So here's the neck bolt that I used with the 5mm hole in it. I'm fortunate enough to have a small lathe that handled the task okay, but I think you should be able to do it in a drill press, or if you're really steady you could do it with a hand drill. So we'll just talk about the self-tapping screws that I use. This first time I used these screws, that was from a supplier here in Australia, and they're designed for plastic, so they call them high plas or plastite self-tapping screws. They're tri-lobal. I don't know what that means, but that's what they say they are. But they work really well tapping into 3D printed plastic. So I'll definitely use them more often. And if they're not available, I guess you could use standard self-tappers. So the file set that I'm going to distribute has a complete building materials list, which includes these screws, these self-tapper screws, and all the metric screws that I used as well in assembling Marvin. So I think that's about it for this first part of the video. The next one we'll talk about the body and the GPP assemblies. So until next video, thank you for watching, and we'll catch you later on.